Welcome to This Explainer. Today, we're diving straight into the fascinating, layered world of artificial intelligence. We're going from the apps you literally have in your pocket right now, all the way down into the complex, beating heart of neural networks. So let's just jump right in and start peeling back the layers. Have you ever actually stopped to think about how your phone recognizes your face? If you're unlocking your screen with Face ID, or letting Netflix pick your movie for the night, or checking exactly when your Zomato order is going to show up, guess what? You're already an AI power user. This stuff isn't some distant sci-fi fantasy anymore. We're interacting with it literally every single day. So here's our roadmap for today. We're looking at AI in everyday life, the true meaning of machine learning, the 3 types of ML, deep learning and neural networks, and finally, generative AI and the future. Think of it like a matryoshka doll. We'll just peel it back layer by layer. All right, section 1, AI in everyday life. Broadly speaking, AI just lets computers do things that usually require a human brain, like spotting patterns or understanding speech. But the way we actually pull this off today, it's a massive, massive paradigm shift. Look at traditional computing. A human writes the rules, feeds in some input, and boom, you get an output. But with machine learning, which is basically the engine of modern AI, we completely flip the script. We feed the machine the input and the historical output data. And the machine, it figures out the logic all on its own. We aren't hard-coding rules anymore. We're teaching these systems to actually learn from the data itself. Moving right along to section 2, machine learning's true meaning. Let's look under the hood. How does processing all this data actually lead to independent decisions? Well, almost all machine learning models follow 2 steps, training and inference. Imagine you work at a bank, okay? And you need a system to decide if a new customer gets a loan. Step 1 is training. You feed the system a ton of past data, credit scores, salaries, who got approved, who got rejected. The machine quietly finds the hidden patterns. Then step 2 is inference. A brand new applicant walks through the door, and the machine uses everything it just learned to predict whether they should be approved. It's really that simple. Which brings us to section 3, the 3 types of machine learning. So machine learning basically sits on 3 main pillars. We've got supervised learning, which learns from strictly labeled data. Then unsupervised learning, which hunts down patterns in completely unlabeled data. And finally, reinforcement learning, which learns through a system of rewards and penalties. Let's break these down a bit. First up, supervised learning. This is where we spoon-feed the machine heavily labeled examples. Like we literally tell it, hey, this email is spam, and this one isn't. This approach usually tackles 2 types of problems. First is classification, where the output is a specific category, like our spam versus not spam example. The second is regression. This is where the output is a continuous number. Think of analyzing past traffic routes to predict that your delivery is going to arrive in exactly, say, 43 minutes. Next, we've got unsupervised learning. Now, imagine dumping a massive pile of raw, unlabeled data onto the computer. You don't tell it what the categories are. You just say, hey, organize this chaos. It naturally groups related data points into clusters. A great example of this is market basket analysis on sites like Amazon. The machine notices, totally on its own, that, hey, people who buy bread often buy milk. It found that connection with 0 human tagging. It's also incredibly good at spotting weird anomalies, like a sudden fraudulent login attempt from 5 different countries all in the same minute. Then there's the third pillar, reinforcement learning. I absolutely love this analogy. It is exactly like training a puppy. When the dog sits on command, you give it a treat, right? Positive reward. If it chews up your shoes, no treat. In reinforcement learning, the AI operates in an environment where its ultimate goal is to absolutely maximize those rewards. This reward-chasing behavior, that's exactly how AI masters ridiculously complex games like chess, or how self-driving cars figure out how to navigate real-world traffic without crashing. All right, on to section 4, deep learning and the machine brain. So traditional machine learning is fantastic when you have nice, neat, structured spreadsheets. But what happens when we throw something messy at it, like raw images or a video file? For that, we need a digital brain. Deep learning uses artificial neural networks, which are literally inspired by the neurons in your own head. Check out the architecture here. Input layer on the left, some hidden processing layers in the middle, and an output layer on the right. And connecting them all are these things called weights and biases. Think of weights like a professor calculating your final grade. Maybe midterms have a high weight, say 40%, but pop quizzes are only 10%. If students stop doing the reading, the teacher might adjust those weights. Well, neural networks do exactly the same thing. They constantly adjust the weight of different inputs until they get a really accurate final prediction. But how do they actually learn to adjust those weights?
It happens in two continuous steps: forward propagation and backward propagation. First, data flows forward through the network, and the AI makes its best calculated guess. Then, during backward propagation, the network looks at the actual right answer, sees how badly it messed up using something called a loss function, and then literally moves backwards through the layers to tweak those weights. It just learns from its mistakes over and over until it gets it right.
Now wrap your head around the sheer scale of this math. If you feed a standard 1,000 by 1,000 pixel image into a basic neural network, that's 1 million input values, right? And because it's a network, a single neuron in that hidden layer has to compute 1 million times. And if it's a color image, multiply that whole thing by 3. Traditional neural networks just completely collapse under the massive computational weight of visual data. So to solve this visual overload, we use CNNs, or convolutional neural networks. Instead of staring at every single pixel all at once and melting your hard drive, CNNs scan the image in small, bite-sized patches. They're basically just looking for edges, corners, and shapes, which drastically cuts down on the math required. This right here is the exact backbone technology that makes Face ID work or lets those city traffic cameras instantly read your license plate.
But wait, what if your data isn't an image at all? What if it's a sequence, like a sentence or a stock market trend? For that, we use RNNs, or recurrent neural networks. Unlike standard networks, RNNs actually have a memory. They remember the stuff from previous steps so they can understand context. I mean, you can't translate human language if you don't know the context of the words that just came before, right? Which is exactly why RNNs have traditionally been the heavy lifters for language and speech recognition.
And that brings us to the next massive, massive leap: transformers. Transformers completely revolutionized the AI game. Instead of reading a sentence slowly, word by word, like an RNN, transformers look at the whole sequence simultaneously. They use this absolutely brilliant mechanism called attention to instantly figure out which parts of the data are most important to each other. It gives them this incredibly deep grasp of context. And yeah, if the word transformer sounds familiar, it's for good reason. It is the literal foundation of all the modern AI chatbots we use today. Which perfectly tees up Section 5, Generative AI and the future. We are officially moving from AI that just analyzes and sorts old data to AI that miraculously creates entirely new data from scratch. This is where the real magic happens. Generative AI completely shifts the focus. We aren't just classifying things anymore. We are generating brand new text, audio, images, and mind-blowing high-def video out of thin air. This is the playground where heavy hitters like ChatGPT, Midjourney, and Sora actually live. To really get how these tools pull this off, let's do a super quick glossary check. First up, NLP, or natural language processing. This is simply the subfield of machine learning dedicated entirely to teaching computers how to understand, interpret, and generate human language. English, Hindi, French, you name it. Whenever you see a machine fluently handling human text or speech, you are watching NLP in action. And the engines powering those NLP tasks today, those are LLMs, or large language models. And trust me, they are large for a reason. They consume an almost unimaginable amount of data during training. We're talking millions of books, articles, and websites, basically gobbling up the internet. LLMs, like OpenAI's GPT-4 or Google's Gemini, are the specific powerhouses driving this whole generative text revolution. Having a mental map of this current generative AI landscape is incredibly empowering, because it shows you exactly what tools are sitting right there waiting for you. Need to write something? You've got LLMs like ChatGPT, Gemini, and Claude. Need a custom image? Fire up Midjourney or Dolly. Want to generate a whole video sequence? There's Sora. And if you're a programmer, tools like GitHub Copilot are literally writing functional code for you based on a simple text prompt. It's absolutely wild. And just like that, we've reached the center of our Matryoshka doll. We've peeled back the layers, from everyday Netflix recommendations down into the mechanics of machine learning, through the complex neurons of deep learning, all the way to the raw creative power of generative AI. So I want to leave you with this final thought to ponder. From letting simple algorithms filter your daily spam to using transformers to build entirely new worlds, how are you going to utilize these foundational AI tools to empower your own life and work? Think about it. Thank you so much for joining me on this explainer, and as always, keep exploring.